All right. Well, thank you everyone for jumping on. If you're just joining us, my name is Spencer Herman. I'm going to be guiding us through this conversation today about batteries. I want to thank everyone so much for their time, for participating and listening in. We have a great discussion here for you. And before we get into it, I just want to say, so here we are, and we're being hosted by the lovely folks at the Coretec Group. The panel will consist of Dr. Michelle Tokarz from Cortex. She's the VP of Partnerships and Development. She will be joined by Chris Silkowski, the Director of Development at Navitas Systems. We're waiting. Hopefully, we'll also be joined by Dr. Henry Mao, Chief Engineer for Cell Commercial and Production at Enpower Greentech. But first, before we jump into their conversation, I just want to throw it to Cortex Chief Technical Officer, Dr. Ramez Elgammal, who will give a quick little introduction and update on what's been going on at Cortex recently and what we can expect to see in the near future. So, Ramez?
Yeah, thank you for that introduction, Spencer. Yeah, so we're excited to give you an update today on our Endurion project. And so really the impetus for the Endurion project came from thinking critically about what's necessary and what's missing from silicon-based anodes that have impeded their commercialization, and thinking strategically about also what's missing from the IP landscape, because an important part of this approach is not only having something that we can commercialize, but something that's distinct and where there's a differentiator from other approaches that are in the market. And so we're happy to say that we're making great progress. The approach that we're taking with our silicon nanoparticles is based on engineering an artificial SEI. And so basically, the way to think about what an SEI is, it's a layer that is formed during cycling of a battery, and really the way to kind of make it better is to think about how you can control the environment around the active particle so that you're not losing lithium, so that you have stable cycling, and that's what we're trying to do. And not only that, but really increase the energy density. So there's a metric that exists in the industry where if you want to think about an energy density pushing past 500 watt hours per kilogram, and so that our designs are really focused on meeting those benchmarks, and those benchmarks are coming a lot from our conversations with partners or potential partners, and our discussions with a wide variety of folks from automotive to material producers. And really what we're trying to do is think about how to design electrodes that lead to different types of batteries, so that we can capture applications not just in EVs, but in eVTOL, in wearables, really have our engineered artificial SEI be a portable technology where it really can become a drop-in replacement. So thinking about where we started this year, Nathaniel Downs, Dr. Nathaniel Downs came on board, and he's our chief scientist in Ann Arbor that's doing a lot of the heavy lifting in the lab. And it was really validating the proof of concept, demonstrating that our approach to engineering these nanoparticles is providing an advantage over unmodified material. So really having the right control experiments. And so that started out teaming up with the battery lab at the University of Michigan to do our initial testing, and that really got us going with getting some preliminary data to kind of seed the development. And we also partnered with Polaris Laboratories in Portland. So they have expertise in developing slurries and thinking about the rheology or really the best way to make electrodes. And a lot of valuable data was collected from our collaboration with Polaris, and Nathaniel even went out and worked with the Polaris scientists to get a lot of hands-on experience using their equipment, and all of that, both our work with University of Michigan and with Polaris, gave us kind of the necessary guidance to set up our own testing facility and cell making facility in our lab in Ann Arbor, and really that is a crucial component to accelerating the development. And we took our results from our proof of concept experiments that demonstrated that the Endurion approach is offering an advantage over incumbent technologies, and filed a provisional patent application in May of this year. And we're continuing expansion of that technology to really think about ways to keep building up our IP portfolio. And here it's basically from not just making new materials, but new manufacturing approaches to have a broad and defensible IP portfolio. And and so I really can't stress enough the importance that having our in-house lab has been, and we've now brought on a skilled technician to help Nathaniel with the cell building that's really going to accelerate our development. And really, the Coretec Group at its core, we're trying to demonstrate that that we have this expertise in engineering silicon, and that's really become the mission statement of the Coretec Group. And what we want to do is be able to engineer these particles so that they're an easy, commercially viable drop-in replacement for graphite in silicon anodes. And so really where we'd like to go, so we like to keep pushing the silicon loading in the cells that we're testing, and so that's going to get us to the 500 watt hour per kilogram targets, and think strategically about how to source materials to accelerate scale up and make sure that we're really capturing everything in the various aspects of the supply chain that will be necessary to have a commercially viable process. And so in addition to meetings that we've had with automotive companies, battery companies, and other partners, we're also working with Enpower Greentech and Navitas. Both of those companies are here as panelists today about testing our battery materials and really implementing the Endurion approach and ideally in cells that they're already making. And while we've been looking at coin cells, we're making an aggressive push to design pouch cells that we hope to have going by end of the year, and that the next generation prototypes are going to attract both interest from electric vehicle companies as well as the military, and these where we can be able to design both high energy density and high power density batteries depending upon customer spec. And we're really looking forward to engaging with multiple markets and providing materials to strategic partners to independently evaluate the breakthroughs that Endurion will deliver.
Thank you for that, Ramez. I'm excited to see what comes next. And with that, I think we can dive into this battery discussion with Michelle and Chris. I want to start things off on maybe a note of positivity. I'm curious, between the two of you, what are you most optimistic about right now regarding the future of battery technology? What's giving you hope? What are you excited to see continue? Yeah.
Chris, you want to start? You want me to take that?
Sure, I can start on that. I mean, honestly, what I'm looking forward most in the battery world is stability. It's a Wild West right now, and there's a lot of people building a lot of stuff and not knowing how to do it or where to get the stuff and what to do. and it's all just a little crazy right now. And so, from a purely non-technological standpoint, that's what I hope for the industry is some measure of stability and a little more sanity soon. Technologically, I guess I frame everything in terms of pain points, and so in terms of technology pain points, the energy density is of course the perennial one, and then tied to that, very importantly now is safety. And so what I'm looking forward to are technologies that essentially just solve the energy density and safety problems or challenges. And so there's many technology that promises to address it, but the real, I don't know, the ones that are most likely to work out are there will be flavors of advanced lithium ion until that next sort of breakthrough occurs, and maybe solid state battery or something of that ilk. So that's kind of what's on my mind. Michelle?
Yeah, building off what Chris has said about stability, in the wild, wild west. I just spent several days at the battery show in Novi, and a lot of people doing a lot of different things. I would say I'm starting to see a lot of collaboration. A lot of people that have expertise in different areas of the value chain willing to work together. I also saw, quite a bit of people wanting domestic sources, so U.S. sources, and I attribute that directly to the Inflation Reduction Act. I think that's going to be pretty huge. And then obviously for us, we're working on silicon anodes. We hope to, there's a lot of people that have done silicon anodes, but they have not been very successful in the cycle life. And that's some of what Ramez has touched on with the SEI layer. We're hoping to get a good handle on that and make some progress.
Fantastic. This kind of leads right into my next question, which is about the United States government's goals for EV adoption by 2030, which are quite lofty. I'm curious what you guys think what will it take to achieve some of these goals? What do we need to expand EV adoption to get to the point where we can achieve some of this widespread adoption of the technology in that time?
And I'm going to pass that to Chris. I think Navitas is best situated to kind of answer some of those questions. I'm curious what you think, Chris.
Well, I kind of sit on the sidelines of EV. It seems to me that I'm not sure I know how to answer it very well in terms of like EV stuff or attached to megatrends, I guess. Like, I don't know. Let me see what Michelle has to say, and I'll see if I get a jumping off point there.
I think just like I said, getting the IRA out there, getting that more detailed, and there's also the whole funding piece. There's looking at SBIRs as TTRs. The government should be involved with early research to get these new ideas off the ground.
Yeah, there does seem to be while private industry is certainly good about investing in batteries now that it's hot. Traditionally, it really hadn't done much of that, and government was really crucial. And a lot of the technology and opportunities that you see today were directly linked to particularly Department of Energy and Department of Defense, maybe to a little smaller degree, but the funding and DOE has been a huge part of that. We wouldn't be here where we are without DOE, and we wouldn't be getting to that kind of next collection of battery technologies that will probably help with the adoption goals more than the current technology does. So even little changes are hard to come by now in batteries, since the technology is fairly mature in lithium ion, but there are adjustments that say like help with the fast charging or help here or there, and those little things are those last really annoying points that need to be or should be solved before you really get like wide adoption.
Okay, makes sense. I'm curious then, Chris, how essential do you think lithium-ion anode innovation is going to be to the future of large-scale EV battery manufacturing?
I think in the near term, and so near term is probably next 10 years or so, but there's billions of dollars that have been put into and are being put into factories built on conventional cell assembly technology. So electrode coating, everybody knows how to do it through slurry coating. Dry process coating is coming. There's other technologies coming, but they're not really validated. And we're talking about industries that have to be risk adverse, right? Because there's just so much liability involved with jumping into new technologies that are unproven. So that old stuff or old technology is going to be the way that battery is done for quite a while. And so you need to have advancements that play nicely with those production methods. And so things like silicon anode, which if you do it right is a drop-in those systems, then they definitely add value. And so just by virtue of playing with existing systems, there's value that can be added. And then of course they can stand on their own as well, but they will, play nicely with the way that people are now compelled to build batteries for, the next, I don't know, big chunks of their career. These plants could be around for a while.
Yeah, people have been working on the cathode side for years, and largely because the cathode is such a volume-wise and cost-wise, it's such a large part of the entire battery. And so the anode has largely been ignored. It's been graphite for very long. So to get that last bit of improvement out of that battery, anodes are the way to be looking, and silicon anode would definitely be the next step.
Okay, fantastic. I'm curious then now, what role should the national government be playing in aiding battery innovation? So should be taking a more active currently. How's it doing currently to your account? I'm curious where you guys stand on, the role of government, either incentivizing or funding, and where that fits in.
So given that my paycheck essentially comes from the government, I have a little bit of a conflict of interest in this answer. But so yes, I think, government does serve that role in the US, research and development ecosystem of making bets on things that are a little too risky for industry, right, to make bets on, and maybe not, appropriate for academic research. So it is very important. And so yes, it's important. And then, like, do you need more or less of it? I think, I don't know, probably about the level of funding that goes into it all now seems to be about appropriate. And then, then you may want to focus some funding on getting things to the finish line. And so the Infrastructure Act bill and things like that are going to take getting a number of things to the finish line, And that's, I think there's that double whammy of getting things to the finish line and then keeping the hopper full with some, at least some new ideas. That doesn't have to be all lithium-ion. There's certainly beyond lithium-ion that needs to get worked on as well. And you?
Yeah, I'd said before, SBIRs, STTRs, that's kind of, where a lot of people look for the early innovations. As Dr. Ramez Elgammal talked about, our work is highly technical and it's fairly early. We're in the early stages. We're moving fast. We're laser focused. We're getting some good results, and that's the perfect place for government to step in and to give us those kind of funding resources that we need to get to the next step. And as Chris said, to get it over the goal line.
Perfect. And we are joined now by our third panelist, Dr. Henry Mao. Thank you so much for joining us, Dr. Mao.
Thank you. Thank you.
Good
morning, everyone.
Sorry, go ahead. Good morning. I want to throw a question to you. I'm curious. So Enpower Greentech is working on several different batteries at the moment. I was wondering if you could just give, to get us started with you, a brief overview on some of them and the chemistries behind them.
Okay. Enpower is basically three areas. Number one is they are all solid electrolyte batteries development. That work is mostly in Japan, in Tokyo, Oklahoma. In they already have the already made the all solid electrolyte batteries can run for a few hundred cycles, but that it's all solid, and they can make the all solid electrolyte sulfur material. They can make the material. This material is amazing. It's called a super ionic conductor. It can be the conductivity. It's about it can be the same as the liquid, even exceed the liquid conductivity. This is amazing material. Was invented by Dr. Kano at the Tokyo Tech University. The conductivity is extremely high. So that's the part of their job work for all solid electrolyte. They can build up small test cells and they show the all solid electrolyte properties. The only thing is you need for now is you need a bit of the pressure. So to get all the particles contact each other. This is the one part of work. The second part of work is the semi-solid electrolyte. This one, with this one, they build up the cells and sold to the cells are built in Beijing, China. Was sold to the drone companies. So the energy density is in the lab can go to close to 600 watt-hour per kilo. Yeah, but the batteries sold is not as high. It's over about 450 watt-hour per kilo. But it's they will have a 0.3 gigawatt-hour factory built in China by end of this year. So that was basically used in the drone business. The third part of the work on lithium-ion battery is the iron phosphate factory. That factory is set in Ann Arbor, Michigan. The first pilot line, it's a 0.2 gigawatt-hour lithium-ion prismatic cells. The target market is the automotive or some energy storage. This factory will be up running next year and provide the samples to the automotive customers. Starting from June, July time. So they already finished the design and acquired the factory space and building up the factory in Ann Arbor, Michigan. So these cells will be made in the U.S. and will be these cells will be have the advantages of a lower cost and long cycle life. With the technology, the energy density for these cells will be higher than conventional lithium iron phosphate batteries, and these cells will be 100% recyclable. And for these ones, they call it Horizon platform. They have different platforms. As I said, they have 3 platforms. One is for the all solid electrolyte. One is the semi-solid electrolyte for the drones, and this one is called Horizon platform for lithium-ion prismatic cells.
Perfect. I want to throw a question now to Dr. Tokarz. I'm curious about what are the advantages? Coretec is very focused on the advantages of silicon nanoparticles. Why is that a better solution than traditional silicon for a lithium-ion battery anode?
Yeah, silicon in general has a big expansion and contraction problem in batteries that people have known about for a while. And those forces of that expansion and contraction tend to make it buckle, it falls apart, many problems. When the particles are too large, that contraction and swelling in those forces has the effect of causing pulverization, which can disconnect the anode from the current collector. And then you've got a dead battery, or at least you've got dead lithium that won't go anywhere. Using nanoparticles, and our nanoparticles are less than 150 nanometers. When they're that small, they do still swell and contract, but they're not so much to the point where they're going to pulverize and they're going to lose contact with the current collector. So, and that the nanoparticle size in conjunction with our unique SEI layer should allow us to remain in contact with that current collector and improve the cycle life.
Perfect. That's great. And then I want to throw a question to Chris, but anyone, feel free to jump in. I'm curious at Navitas, what are the biggest hurdles facing you and your team in the battery development process? And if there's any kind of clear path to overcoming those hurdles, or, what your team's hoping how to get around them, anything in that realm at all?
Our headache is like our technology, and our technology is lithium-ion. So we have our hands around that fairly well. What we struggle with are the multiple valleys of death between, starting a project and releasing it for production. So battery R&D is very time intensive and expensive, as Michelle has figured out now. And advanced manufacturing and development, long time, expensive. Setting up a production plant, a pilot plant even, takes a long time and is expensive. And then transitioning to production, you need, a considerable fraction of $1 billion and, 1+ years to do that. So all in, from idea to commercialization, it's years and $1 billion to make it happen with a new battery idea. And so Navitas in many ways is like kind of replowing treaded ground, but even for us, it's painful just to get to these, getting the right investments that let us scale up when we need to scale up and care for our customers. So that's my headache. And certainly the government, as well as private industry now, right? There are abilities to generate funding to get that done, but again, it's not overnight, and then it's just sort of an unsatisfactory ride for many people because it's not fast either. Thanks, Spencer.
Yeah, no, absolutely.
I want to jump on that too. That that's the whole reason we partner, and that's why we're talking with the Navitases, with the Enpowers of the world. We're very good at the early stage, the research and development. We know we need help and partnerships with scaling and that expertise. So that is crucial.
Mm-hmm.
And Dr. Mao, I'm curious, Enpower Greentech has a big global presence. What advantage does that give you guys? How is that helpful in your development process, taking such a global approach?
The development of the lithium-ion batteries, from a history point of view, it started in Japan. Earlier years, in 1992, Sony in Japan released their first lithium-ion batteries to power their video cameras. So they have earliest technology in Japan. After many years, say especially in after the year 2010, the Chinese companies catch up. They build up more and more the production capabilities. So they developed all the suppliers, so material suppliers, and equipment supplier, and human resources suppliers in China rapidly. Now the largest, highest scale of lithium-ion production is still it's already firmly in China. So they have a lot of production resources there. So we looking for the most readily available resources worldwide. So we know the best technology still in Japan, but best production is in China. And we combine all these two, move to the US, we can have the best resources from production, manufacturing from China, and the best technology for all solid electrolyte from Japan. So that will be added to our advantages, competition advantages.
Sorry.
And then here,
Yes, that makes total. Sorry, I was muted. So the last major question, I'll start by posing it to Dr. Tokarz, but everyone feel free to jump in. I'm curious, to your account, each of you, what are the key factors making consumers hesitant to adopting EV technology? And then what are you doing particularly to address those concerns? How do you feel that, you know, the work that your company's doing is trying to alleviate some of that consumer hesitation?
You know, everything that I've heard from trade shows, from talking to friends, et cetera, it's still range anxiety, which kind of surprised me, but that is what I hear. But it's range anxiety, you know, how far will my electric vehicle go on a single charge, combined with availability of charging units. And that's a difficult thing. You know, if you're in the government, you're trying to figure out, you know, how many charging units to put out. You want exactly the right amount to match the number of electric vehicles. It's a chicken and egg kind of a scenario. But that is mostly what I hear. You know, my car is easy. I fill it up with gas. There's a gas station every 5 miles. I'm good to go. That's what I hear is range anxiety. And what are we doing? We are increasing our energy density of our anode, which will give you greater range and ability to get to that next charging station.
Anyone else want to chime in before we say goodbye with what we're doing to alleviate some of these consumer concerns?
Yeah, I'll get my 2 cents in on it. It seems to me that convenience is a major barrier in EV adoption, and so technologically, it's, you know, it's not exactly the best it can be, but it's certainly good enough to seed a market and get popular. But there's just a huge swath of people that really can't do current state-of-the-art EV. And this, you know, if you have a garage where you can charge your vehicle, or you are, you know, next to an IKEA that has free chargers or whatever next to it, sure. But you're a small part of the population. Where you really want these things is in urban populations where just owning a car sucks. And now I have to charge it on some like infrastructure that's not really ready, you know, for me yet. And so it's not, you have to put in effort, and people don't put in effort in things that are, you know, have evolved to the point where they're just appliances, right? So you're certainly going to get EVs into the hands of enthusiasts and people who want to do it, but the mainstream person is going to be resistant until things just get a lot easier for them. And my second point is, if I'm living in Minnesota, do I want an EV at all, ever? Because I have winter there, and winter is bad for EV. So I think there's still going to be a lot of call for ICE engine vehicles, and there will be a sort of a geographic divide, I think, on who really, you know, benefits from EVs and who doesn't.
Well, that's the last big official question I have for you. I was hoping though, before we go, if maybe starting with you, Chris, because you were just going, any final words on the state of the industry before we wrap this up?
That's, I don't know. It's a good time to do batteries. I grew up in the lithium-ion battery industry, and so it's interesting. You know, people have asked me like how this thing that just used to be like a lab novelty in the United States, and now it's like grown up into a major thing. How do you feel about that? And it's like, it's annoying. Everybody's in the way, and I can't do my work anymore because there's so many mouths to feed now. This will all stabilize, and batteries will become like a lithium-ion battery. It's like, it's already commonplace. It's just going to become increasingly commonplace in more applications, and the supply chain and ecosystem will straighten it all out. It's again, like you can't go wrong working in batteries right now, I think, if you are smart about it.
Dr. Mao, any final words on the state of the industry?
I like the word cannot go wrong if you work in the battery business. I think the battery industry is going to grow much bigger in the US, and the economy will be better because you have electric vehicles all over the United States. Yeah, that's it. I have been working in the lithium-ion industry for a long time. I hope this will be as a time continues the time for many years to come.
And Michelle, any final words before we say goodbye?
Yeah, I want to put a plug in for Coretec and our Endurion project. It is working. You know, Ramez laid out kind of the vision at the beginning of the call, talking about how to do an engineered SCI layer, how to take advantage of nanoparticles, how to do all these things that have not been done with silicon anodes to date. We have been doing them. We have been making the modifications. We've been testing them, and we are seeing the results. We're heading in a good direction, and our proof of concept is working. So we're going to continue charging forward.
That's very exciting. Well, thank you to the three of you for taking time out of your day. And then, of course, Dr. Elgammal for doing that as well. And all of you who participated and attended, thank you so much for listening in. I learned quite a bit, and I hope you all did too. This was fascinating. Thank you, everyone.
Okay, thank you.
Thank you.
Thank you all.
Okay, thank you.